Hey math kids, today we're going to talk about stationary points, and we've already kind of talked about this a little bit, but we see them right here. This is called a local max. And then if we have a parabola like this, or just a curve on a graph, this is a local min. So if we go up and then come back down, that point where we're horizontal for a moment is a local max. If we go down and then go up, that's called the local min. And then we also have another thing called a stationary inflection. And that's where we go down, go horizontal for a moment, and then continue to go down. So this is called stationary inflection. Okay? All right, so what we're going to do, we're going to use derivatives and etc. to figure this out. So it says find and classify all stationary points of this function. Okay. So we're given f of x, and I'll scroll up. All right. So the first thing is to find any stationary point, we just want to know where the derivative is equal to 0. So it's similar to what we did on the previous video. So I take the derivative, set that equal to 0. All right, I can factor out a 3 from this. And then I can t-factor. And so we get x plus 1, x minus 3, and then this 3. All right, so we set each piece equal to 0. We say 3 equals 0, x plus 1 equals 0, x minus 3 equals 0. And from that, this doesn't make any sense, so we throw it away. Subtract 1, so x equals negative 1, and then we add 3, so x equals 3. All right, so we make our sign diagram. We get negative 1 and 3, and then we pick our points or our values that fall in between those. Those ones in yellow are the ones I'm going to choose. And then we can plug them in to this thing. Now the 3 doesn't matter, so I'm getting rid of that. But if I plug in a negative 2 here, we'll get a negative number. Plug in a negative here, we'll also get a negative. Negative times negative is positive. Okay, right here, plug in a 0, get positive. Plug in a 0, get negative. Positive times negative is negative. Plug in a 4, get positive. Plug in a 4, also get positive. Positive times positive is positive. Okay, now what we're going to do is just draw like a rough sketch, but we're going to go up and then get to that point and go down. And so that's going to be a local minimum. So at x equals negative 1. And then this one, since the slope is negative, we go down and then we come up. Oh wait, sorry, that was local maximum. And then this one, we go down and come back up. And so at 3, we have a local minimum. Okay? Moving on to the next one. So we're going to, it says find the exact position and nature of the stationary point of this. Okay, so stationary point means we take the derivative, set it equal to 0. That's the first thing. So this is going to be a product rule. So we write down the first one, the derivative of the second one, plus the second one, times the derivative of the first one. Okay, set this equal to 0. So we don't really need that. I'm going to subtract this over here. So we get negative e to the negative x is equal to, actually, let's, I take that back. Okay, so in both of these we have e to the negative x. And so, but actually I'm going to take out the negative e to the negative x. So I'm going to take out this from both of them. So if I take that out, negative e to the negative x. So this one we're left with x minus 2. I'll even do extra parentheses there. And then right here, we take out e to the negative x, but since it's positive, we need to leave a negative 1. Okay, this is still equal to 0. Then we simplify this. This is x minus 3. So now we have x minus 3 and negative e to the negative x. And so if we set both of those equal to 0, negative e to the negative x equals 0, and x minus 3 equals 0. We just add 3 over here. We get x equals 3. And then over here, we're going to divide by negative 1. That doesn't really matter. And we natural log both sides. So we get negative x is equal to natural log of 0, which if you try to do natural log of 0, it's undefined. And so we just kind of throw this one out there. Okay. And so we just have the 3. And if we plug in, or sorry, this is the only place that we have the stationary point is x equals 3. And so we draw our sign diagram. At 3, we choose values on both sides. I'm going to choose 0 and 4. And if we plug it in to our derivative, that will help us. So if we plug in a 0 right here, we're going to get negative 0, which is just 0. E to the 0 is 1. 1 times a negative is going to be negative. Plug in a 0 here. We also get negative. Negative times negative is positive. Plug in a 4. This is going to be, it's a little bit harder to see. Okay, so that's what we end up with. So that's like saying negative 1 over e to the 4th, which is a negative number. And then this one would be positive because it would be just 1. So negative times positive is negative. And so that's our sign diagram. And if we go positive and then negative as far as our slope's concerned, that is a local max at x equals 3. Cool. We have one more example. It says find the greatest and least value of y equals x cubed minus 6x squared plus 5 on the interval negative 2 is less than x is less than or equal to 5. Okay? So, this we need to test a few other things. So what we're going to do we want to find our stationary points. So we take the derivative of the top, 3x squared minus 12x, set it equal to 0, factor, and then set each of those equal to 0. This gives us x equals 0 if we do the algebra. And this gives us x equals 4. Okay. So we have 0 and 4. Do our sign diagram. So I'm going to look at negative 1, 1, and 5. If I plug in negative 1 here, I get a negative. Plug in negative 1 here, it's negative. Negative times negative is positive. If I plug in a 1 here, I get positive. Plug in a 1 here, still negative. Positive times negative is negative. Plug in a 5 here, positive. 5 here is positive as well. And so we end up with a positive. So we go right here. So that one we have a max. Right here is going to go down then up. So that one's a min. All right. Now, we also need to test the we need to test these, see how high up or low, like high or low they are. And so what we're going to do is, these are called critical values. So we have an endpoint at -2. We have a max at 0. We have a min at 4. And then we have an endpoint at 5. Now we just need to plug these in to see the y values, and then we can answer that question just into the original. Okay, so if we plug in -2, we get -2 cubed minus 6 times -2 squared plus 5. And so that's -8. -2 squared would be 4. 4 times -6 is negative 4 times -6 is -24 plus 5. Add those together, we get -32 plus 5, and that's -27. Now if I plug in a 0, that goes away, and so we're just left with 5. And then I'm not going to go through the simplification on this, but if I plug in 4 for both these x's, simplify it, I'm going to end up with -27. If I plug in a 5 for both these x's, simplify it, I'm going to get -20. Now, it wants us to know, to say the lowest point and the highest point. So obviously the highest point is this one, because 5 is the largest number out of all of these. And so we say the highest point is going to be 0, 5. Now the lowest point is actually tied with the endpoint and the minimum. So we have to list both of them. So -2, -27, as well as 4 and -27. So once again, this yellow one, or sorry, this white one is the highest point on that graph in between that interval, and these yellow ones are the lowest points on the graph in between the interval. If you need additional help, please come to Math Lab. Until then, calculator.